Hello, my name is Ilse Scaret Moya Castro. I'm materials engineering student from Instituto Tecnológico Superior de Irapuato. Today I will present my project titled Feasibility of a Multilayer Biofilter based on corn cob, derived biochar and zeolite for water hardness reduction, with evaluation of the biological stability of the lignocellulosic material.
Water hardness is mainly caused by calcium and magnesium ions. This is a common issue in domestic water systems because it causes scale formation in pipes and appliances, reducing their efficiency and lifespan. This project was inspired by a real problem observed at home, where hard water causes constant scale accumulation in household pipes. Based on this, I proposed a sustainable and low-cost alternative using agricultural waste. The objective of this work was to evaluate the effect of 4 treatments applied to corn cob on its microbial load and biological stability in order to select the optimal treatment for incorporation into a multi-layer biofilter designed for water hardness reduction. The hypothesis was that biochar will show the lowest microbial proliferation and the best filtration performance due to the transformation of its lignocellulosic structure into a more stable and porous matrix. For the methodology, the first step was the characterization of domestic tap water using EDTA titration, where the initial hardness was determined to be 667 milligrams per liter as calcium carbonate. Then conductivity and pH were measured. The corn cob was prepared, ground, and sieved to obtain particles between 2 and 3 millimeters. After that, four different treatments were evaluated: the standard untreated sample, thermal treatment, chemical treatment with sodium hydroxide, and biochar obtained by pyrolysis. To evaluate microbiological stability, all samples were incubated for 28 days and then inoculated and nutrient agar to determine colony forming units. The results showed that biochar had the lowest microbial load, with only 30 CFU per milliliter compared to thermal treatment with 600 CFU per milliliter and the standard sample, which was too numerous to count. This confirmed that biochar was the safest option for integration into filter. Based on this, a proposed multi-layer biofilter was designed using corn cob derived biochar and natural zeolite. The system was tested throughout 4 consecutive filtration runs. For filter 1, the outlet hardness was reduced from 667 to 417 milligrams per liter in the first run, achieving 50% removal efficiency. In second run, the hardness was 583.3 milligrams per liter, corresponding to 30% removal. For filter 2, the first run achieved 10% removal and second run achieved 30% removal. On average, filter 1 showed better performance with an average removal efficiency of 40%, while filter 2 showed 20%. The results support the proposed hypothesis, confirming that corn cob derived biochar is the optimal treatment due to its low microbial load and filtration potential. All throughout, the removal efficiency is still below optimized systems reported in literature. These results are promising, especially because the biofilter was tested without pre-washing or conditioning. As future work, further optimization of the system will be carried out, including porosity characterization, adsorption studies, and the possible reuse of spent filter material as a soil amendment, promoting a circular economy model. In conclusion, this study demonstrates that agricultural resources such as corn cob can be transformed into functional and sustainable materials for water treatment applications. Thank you for your attention.